Hello. So suppose you have a triangle inscribed in a circle, and you have a point P. Here's ABC. You have a point P on the circle, and then you draw the perpendiculars to the three segments. So these are all right angles. It turns out that these 3 points lie on a straight line, and our goal today is to prove it. The proof is relatively straightforward. I'll let you pause for a few seconds if you want to try yourself. And at any point in this proof, if you get inspired, you should try to pause and figure out why D, E, and F are collinear. Okay, I'll start the proof. So we notice that these two are both right angles, and then these two are also both right angles. So what does that suggest? That suggests drawing some more circumcircles. And these won't be accurate, but they'll be good enough. Okay, so the red circle will intersect at B, D, and EP because they are cyclic, right? BEP and BDP both subtend the diameter. And then the same for here. If we connect P to C, which is the diameter, then PEC is a right angle, and then PECF are also cyclic. So immediately we have lots of cyclic stuff. We can start out with angle DEP, which is this. Now, if we want to prove that this is a straight line, all we have to prove is that angle DEP plus angle FEP is 180 degrees. So I'll just write that down. Goal, this plus FEP is 180. So what do we know about DEP? Well, in this circle, DEP is supplementary to DBP. So sup to DBP. But what can we say about DBP? Well, DBP is part of this original semicircle, right? So it's supplementary to ACP. And what does this mean? Well, in other words, it's a long way of saying DEP is equal to ACP, right? ACP is supplementary to PCF, or FCP, right? Because this was a straight line. We defined originally that PF was perpendicular to that line, right? So ACP is supplementary to FCP. But we haven't used this circle, this green circle yet. In this circle, FCP, remember we're trying to relate it to FEP, right? And conveniently, FEP and FCP, they both subtend the same arc of arc PF here. So FCP is equal to FEP by inscribed angles. And now our logic starts to come together. So we can substitute ACP with DEP, and we can substitute FCP with FEP here, leading to the final conclusion that DEP is supplementary to FEP, right? So their sum is 180, in other words, and that's exactly what we wanted to prove, right? That DEP plus FEP is 180, meaning this is the straight line, and we are done.